Hi, how you guys doing? This is Mr. Maestas, and I'll be talking about solving linear inequalities today. That's the learning target today, so our objective is to solve linear inequalities. So let's take a look, some vocabulary that you might need to know. First, an inequality. An inequality is any mathematical sentence that involves a greater than, a less than, a greater than, a greater than or equal to, although I'm sorry, this is a less than or equal to, and this is a greater than or equal to. My handwriting is very sloppy. One thing you want to make sure that you do is you want to make sure that when you solve this, you want to flip the inequality symbol whenever you multiply or divide both sides, okay, both sides, by a negative number. So I'll show you an example of what I mean by that in just a second. All right, so let's take a look at a few examples and a couple practice problems, and then that's it, guys. So let's take a look. Solve each inequality and graph the solution set on a number line, and then we're going to write our solution in solution set notation. So I'll show you what that looks like. So these guys here, they pretty much work just like equations. So you're going to solve them just like equations. I'm going to go ahead and just to illustrate what I meant by switching inequalities, or switching the inequality sign, I'm going to go ahead and graph. I'm sorry, not graph. I'm going to solve this. I'm going to subtract 5y, just like I'm doing with if I was doing this with an equation. Okay, this is just like an equation, only an inequality, and we're really only worried about the end. Okay, so let's add 1. We're going to do everything the same, and then divide by -2. Now when we divide both sides by -2, this right here is the situation where we would change and flip the direction of the inequality. All right, because the reason we do that is because if we didn't do that, then we would end up with y is less than 3, and that wouldn't really work. If we plugged in a 0 here, we would have -1 is less than -7, and that doesn't work. But if we plugged a 4, remember we're talking about anything bigger than 3. If we plugged in a 4 here, we're going to get a true statement. So how do we write this? First, how do we graph it on a number line? Well, on a number line, we're just gonna draw our number line. Okay, we're just gonna draw our number line right here. Okay, and we're gonna label this number line. What I like to do is just go 0, 1, 2, 3, -1. Okay, so we've got 0, 1, 2, 3, -1, and then we will take. We're going to go and take this as an open circle, and it's greater than 3. And a lot of times these things point the same place as long as your y is there, as long as your x or y is on the left side. Okay, it's an open circle because it's greater than, it doesn't include it. So if it's open, if it's either greater than or less than, it's closed like that. If it's greater than or equal to or less than or equal to. Closed meaning that it's equal. It could be that number. Open meaning it might not be. Okay? Okay, so let's take a look at another example. All right, here I have 8 minus 3x greater than or equal to 7. So I'm just going to subtract the 8 here. Now I like to have my my x or my y, whatever the variable is, I like to have it on the left side always for inequalities. And the reason I like to have it always on the left side for inequalities is because this inequality shows me which way my arrow is going to go on my number line. Okay, so on my number line, I'm going to go and draw my number line now. I'll go 0, 1, 2, 3, 4. Oops, that's not very straight. 5. So 0, 1, 2, 3, 4, 5. And this is a closed circle because it's greater than or equal to. Greater than or equal to. So it's closed. And I'm just going to go this way. It's everything greater than 5. That's all these numbers here. Okay. Now, I did forget to mention on the last example how to write it in set notation. So let me show you set notation. Set notation, sorry about that. Okay. I'm trying to get some colors here that match. Okay. So set notation looks like this. We draw a little brace, an X with a bar that tells me that I'm talking about X's. X greater than or equal to 5, and another brace. Okay, so it's just a way to write it. You're just taking this and putting it right there, and then whatever your variables with the X and then a bar here, and this is your set notation. All right. All right. Let's take a look at another one. So here we're going to go and solve this, and the first thing we're going to do is multiply both sides by 5. And we're going to have negative 2 times 3a plus 1 less than 5a. Remember, all we're doing is we're doing the same thing as we would if this was an equation. We're really not doing anything different. The only other rule is if we divided or multiplied both sides by a negative number, we would switch the inequality. Okay, let's go ahead. You know what I'm going to do here? I'm going to go ahead and I'm going to add 2a or 2 to this side, and then subtract 5a. Again, I like to have my variable on the right side. Okay, so I'm going to have a is less than negative. Oh, not less than. Got to watch ourselves, right? A is going to be greater than negative 2/11. Okay, so Kyle, what is that? Let's go ahead and put our answer in set notation. Oops, it's not X. What am I doing here? Just too busy with the X's, right? A is greater than negative 2/11. Okay, and we're gonna go and do our number line here. Ooh, that's a bad line, isn't it? That is an awful line, Mr. Maestas. Let's get something nicer here. There we go. Okay, so wow, here's 0. And here's 1, and negative 2, oh, it's negative 1 here. Negative 2/11, yeah, that's like, you know, if I chop this up in 11 pieces, it's probably around here somewhere, right? Negative 2/11. Okay, so I'm going to draw an open circle, and I'm going to draw an arrow this way. That's it. That's all there is to do with doing those inequalities. All right, so here is a practice problem. I'd like you to try this problem. Just pause the video, and then when you're ready to take a look at the solution, I'll go and finish the solution for you. Okay, so we'll pause right now. Okay, so here are the solution to this. We're going to do 4y plus 7 greater than, I'm going to distribute this out here, so 2y minus 10 minus 1, and then we're going to have 4y plus 7 greater than 2y minus 11. Let's go ahead and subtract 2y here, and why don't we just do this all at once? Subtract 7, and we're going to have 2y greater than negative 18, which is going to give me y is greater than negative 9, because I'm going to divide both sides by 2. All right, so set notation, y greater than negative 9, and number line. All right, so put our number line there, and negative 9, so I'm going to go and put a 0 here, and we'll go backwards here, negative 2, negative 3, negative 4, negative 5, negative 6. You know what, I probably didn't have to go all the way out here, okay? All right, could have just maybe started at negative 5 here. Greater than, so open circle and arrow this way. Okay, and those are answers. All right, there's another practice problem. So again, if you want to pause it, go ahead and pause it, and then I will do the solution. So pause it now. Okay, so here's the solution to this problem. I'm going to multiply both sides by 10. And then I'm going to have negative 3 times 2x minus 4 greater than or equal to 60. Going to go ahead and multiply this in using the distributive property. Then I'm going to subtract 12 from both sides. Divide by 6. And x is going to be greater. Ooh, you got to be careful there. Not negative. Okay. So x is going to be less than or equal to negative 8. So set notation. X less than or equal to negative 8. And number line. Negative 8. I'm just going to start at negative 5 here. Negative 6, 7, negative 8. And then less than or equal to, so I'm going to close the circle and then go this way. Okay. All right. That's all, folks. So that is solving linear inequalities.